Question is like this. Evaluate the value of the integral of the function under root of 8 plus 3x minus x square with respect to x. Now to solve this question, first of all, on observing the given integral, we see that it is in the form of a constant term upon the square root of a quadratic expression. Okay, now to solve such question, first of all, we have to simplify this quadratic expression as the sum or the difference of the square of a variable term and a square of a constant term, right? So, taking the quadratic expression 8 plus 3x minus x square. First thing which we observe here is this, that the coefficient of x square is minus 1. So first of all, I am going to make the coefficient of x square as 1 by taking minus sign common from the expression. So this is how I make the coefficient of x square as 1, and these two terms are going to become negative because they are positive. After this, I am going to take the coefficient of x, that is minus 3. Okay, but I am going to neglect the sign, so I am going to take 3 and divide it by 2, and after that I am going to add and subtract the square of 3 by 2 to this expression. So I am going to get the expression like this. So you can see why I have neglected the sign, because on squaring the negative value, I am also going to get a positive value. So that is why there is no need to consider the sign of the coefficient of x, right? This x square minus 3x plus 3 by 2 whole square can be written as x minus 3 by 2 whole square. This value can be written as, that is 3 by 2 whole square can be written as 9 upon 4. So I am going to get the expression like this. I am going to simplify these two terms. So I am going to get this as equal to minus 9 minus 32 upon 4, which is equal to minus 41 upon 4, this value, plus x minus 3 by 2 whole square. Further, I am going to write the expression like this, root 41 upon 2 whole square, multiplying minus sign, this value, this term is going to become positive and this value is going to become negative. So I am going to get minus x minus 3 by 2 whole square. So we have converted this quadratic expression as the square of a constant term minus the square of a variable term, right? So substituting the value here, I am going to get this integral as equal to 1 upon square root of under root of 41 upon 2 whole square minus x minus 3 by 2 whole square. To solve further, I am going to substitute x minus 3 by 2 as equal to t. Differentiating both sides with respect to x, I am going to get dx as equal to dt. Replacing dx with dt and x minus 3 by 2 with t, I am going to get the integral as 1 upon square root of under root of 41 upon 2 whole square minus t square. Now I know that integration of 1 upon square root of a square minus x square is equal to sine inverse of x upon a, right? So this can be written as sine inverse of t upon under root of 41 upon 2 plus c. Replacing the value of t, I am going to get this as 2x minus 3 upon 2 upon square root of 41 upon 2. These two, both the 2's are going to cancel out because they are dividing the numerator and dividing the denominator, and my final answer would be sine inverse of 2x minus 3 upon square root of 41 plus c. So this is my required answer.